Okay, so math counts week 5, rates and ratios. Okay, so the topics are, I'm going to go over the basics of ratios, and then I'm going to go over something really helpful that you only teach in high school. So I learned this last year, and it's really helpful for rates or ratio problems. And it's like a really helpful trick. So these are called conversion tables. And then we have math counts problems, all right? So ratio basics, what are ratios? I think most of you should know what ratios are, but I'll go over it roughly. Ratios basically represent the relationship between two groups. Relative to one another. Let's say I have a big jar of a big box and there's like balls inside of it. Let's just say the ratio of red balls to yellow balls is 5 to 3. So this means, so to represent ratios, I write this symbol here. It's called a colon. Sounds like my name. So this is a colon, and we use that to represent ratios. Another way to represent ratios is just by a fraction. It's also a way to represent the ratio, but most of the time we use this to not confuse it with fractions. Okay, so what does this ratio mean? This ratio means that for every 5 red balls in this jar, there are 3 yellow balls. So this means that if the number of red balls is 5x for some kind of x, then the number of yellow balls is 3x. Okay, but the problem with ratios is we don't know exactly how many there are. This ratio doesn't mean that there are 5 balls and 3 yellow balls. This means that it's just the proportion between them. Okay, so this means that, oh, the number of red and yellow balls could be 10 or 6. It could be 15 or 9. It could be 20 or 12. Okay, so this ratios only represent the comparison between these two groups relative to one another. So it doesn't tell us exactly how many there are. And to find out exactly how many there are in each group, we will need to have more information. For example, I could say, oh, the number of yellow balls is exactly 9. If I say the number of yellow balls is exactly 9, then we know that there are 15 red balls. Okay. So these are basically ratios. And another thing to know about ratios is because since we can write it in fraction form, we can actually simplify ratios. So let's say I have the ratio 15 to 3. Okay. We can simplify this because ratios are basically fractions. We can write it like this, and we can see how this simplifies to 5 over 1. So we can say the ratio is 5 to 1 instead of 15 to 3. And this will simplify things a lot. So we can simplify ratios as well. So those are what ratios are. Let's go over some basic problems here. So 2 problems right here. Give you 5 minutes to do these. No, how about 3 minutes? These are pretty basic. So 3 minutes. And when you get your answer, you can chat it to me, and I'll let you know if you're right or not. So when you get your answer, please don't chat it to everyone, chat it to just me. So this way you can give everyone a chance to do them.
Hmm. This is so easy. 5-3. 30.
All right, so let me go over these now. First one, the ratio of dogs to cats in the pet store is 5-3. There are 48 pets in total. How many more dogs are there than cats? So one way to do this is we want to find out how many dogs are there, how many cats are there, then we just subtract those. So how many dogs are there in the pet store? Well, it's not 5/3. Be careful here. It's just the ratio is 5-3, which means that for every 5 dogs, there's 3 cats. And as you can see here, 5/3 of the pet store is obviously not dogs, because the maximum we could have is 1, right? Because fractions can't be greater than 1 in this sense. So what is the actual fraction of dogs? Well, let's just draw out, let's just say we have, for every 5 dogs, we have 3 cats. So this means that what fraction of the total is dogs? Well, we have a total of 8, and 5 of them are dogs. So this means 5/8 of the pet store is dogs. So 5/8 times 48, we get 30. Okay, so now let's do the cats. The cats is 3/8 of the whole thing. So 3/8 times 48, 12. So if we, no, not 12, 18. So if we subtract these, 30 minus 18, we get 12. There are 12 more dogs than cats. Okay, so the next one is very, very tricky. It is, they give you a lot of words, and then you get confused, and you don't know what you're actually trying to find. Okay, so this is very tricky. Okay, so a school, library, and a store are all on the street in that order. It has to be in this order. So if we have a bunch of information here, we want to draw out the diagram. So then we have school, and then the library, and then the store. Okay. The ratio of the distance between the school and the library to the distance between the library and the store is 4-15. So let's say this is some 4x, and this is going to be 15x. This is not the scale. Okay. So now we want to find, oh, the store is 7.5 miles from the library. Okay, so we know that this is 7.5 as well. So what's the distance between the school and the store? We want to find this whole distance right here. We want to find that. Well, since we have 4x and 15x here, we can see that 15x is 7.5. So this means that x is going to be 0.3. Okay, so now if we look at this, what we want to find is, no, not 0.3, 0.5, my bad, 0.5. Okay, so x is 0.5. So we want to find the whole distance here, which is 4x plus 15x. We want to find 19x. So what is 19 times 0.5? Well, that's just pretty simple. We can just do some multiplication here. 95, remember to add that decimal, 9.5 miles. Okay, so some people, they said 4, they said 2, because they wanted to find this value. But the question was asking for the whole distance from the school to the store. So this is why you need to draw a diagram so you wouldn't get confused. Okay, 2 more problems right here. I'll give you another 3 minutes and then chat your answer when you get it. Remember to chat it privately. Okay, so for the first one, this is a three-way ratio. So the ratios we've done before, it's just between two objects, two groups. This time it's between three, but it's still the same thought process, okay? So the total amount of money is this. So how much does each person get? So we want to find what fraction of the money does this guy get? So for simplicity, oops, wrong pen. For simplicity, let me start with this guy. You'll see why in a moment. So let's find how much did this guy get? Well, if we think of the money as divided into pieces, let's say this is the total amount of money, divided into pieces, 1, 2, 3, 4, 5, 6. Okay, divided into pieces, we know that the first person is going to get 6 pieces. Second person is going to get 2 pieces. The last person is going to get 1 piece. Okay, so what fraction of the total does this guy get? Well, that's 1 out of 9 total pieces. So 1/9 of the money goes to the third place. That's multiplied by 9,999.99. And as you can see here, this is just going to be 1,111.11 dollars. Okay. And the reason I started with this is because if you did, let's say we did the first one first, then we would say, oh, 6/9, 2/3. If you were to multiply 2/3 by 999.99, that's going to be a lot harder, right? You're going to have to do a lot more math. So now we know that the third place gets this much. That means the second place gets 2 times as much, which means the second place we automatically know is going to be 2,222.22. And the first place, we know that's 6 times as much as the third place guy. So that's going to be $6,666.66. All right. Next one. At a certain location, a tree casts a shadow of 30 feet. Flagpole casts a shadow of 45 feet. If the tree is 18 feet tall, how tall is the flagpole? Well, we know that the longer the taller the object is, the longer its shadow is going to be. So this means that the ratio between shadows is the same thing as the ratio between height. The ratio between shadows is 30 over 45. This is going to be tree over flag. So we're going to have to do tree over flag on this on the other side as well. Okay, so tree is 18 over flag. Let's just say this is x. Okay, so let's do a little bit of simplifying. We can simplify this one first before we cross multiply. It's going to be 2/3. So now we're going to have 18 times 3 equals 2x divided by 2. Well, these cancel. There's going to be 9. 9 times 3 equals x, 27 feet. All right. Now let's go on to conversion tables. So to explain this topic, we're going to have this example problem from the placement test. Ratio of bong to bing is 3:4. Ratio of bing to bung is 2:9. The ratio of bong to bang is 3 to 0.5. Ratio of bang to buck is 4 to 7. What's the ratio of bong to buck? Okay, so we've got to convert these ratios a lot. Okay, so we got to go from bong all the way to buck through all these conversions. Okay, so how do we do this? Well, we could take it step by step, but you'll get confused very quickly. And there's a lot of room to make mistakes. I know some of you got this right on the placement test, but it was probably very hard for you to do these because you got to do so many calculations. So this is where conversion tables comes in. This makes things a lot simpler and it reduces confusion. Let's first start with the first statement, bong to bing. We know that 3 bing equals, no, not 3 bong equals 4 bing. Oops. Right? We know that that's true because the ratio of bong to bing is 3:4. For every 3 bong, there's 4 bing. Okay? What this means is that if we divide both sides by 4 bing, 4 bing, the words bing cancel, the 4's cancel. So we get 1 equals 3 bong over 4 bing. If we're going to do the same thing for all the other statements, we're going to have 2 bing over 9 bong equals 1. 3 bong over 0.5 bang is 1, okay, and so on. The words are really important in these statements because if we didn't include the words, let's look at the first one. 3 bong over 4 bing. If we took out the words, it's just going to be 3 over 4 equals 1, and that's obviously not true, okay? So what do we do here? Well, we got to include the words now. So let's begin converting these. So what I'm going to do is I'm going to draw out a table. It's a conversion table. It's going to look like this. So let's first draw out this table. It's going to look like that. We're going to first start with the first ratio we have here, 3 bong over 4 bing. Note that if we multiply this by any of these ratios that we have later on, it's not going to change the actual value of the ratio. It's just going to alter it so that it works between these different units, right? Because if we multiply this whole thing by 2 bing over 9 bung, that's the same thing as multiplying by 1. And that's not going to change the ratio, the actual ratio. It's just going to change the units, right? It's going to change between bung and bing, right? So as you can see here, if we multiply this value by 2 bing over 9 bung, what happens is, since the words are important, we have to include the words as well. But as you can see here, the words bing will cancel. If we go on, if we multiply this by this, 3 bung over 0.5 bang, note how the words bung are going to cancel. Now I'll multiply this by the next one, which is bang to buck, 4 bang over 7 buck. The words bang will cancel. So all that we have left is 3 times 2 times 3 times 4 bongs over 4 times 9 times 0.5 times 7 bucks. So we already got our answer here because this is going to be 3 times 2 times 3 times 4 times bong over 4 times 9 times 0.5 times 7 times buck. So this is just a ratio between bong and buck. We already got the answer, okay? So this is how conversion tables work. We set up this table and we multiply it by these conversion factors, which all equal to 1. So it's not going to change the actual ratio. It's just going to change the units. And the words will cancel out. And all that we have left is bong over buck. All right, so now all we need to do is evaluate whatever this lot is. 3 times 3 is 9. These cancel. 2 and 4, we got a 2 down here. 2 times 0.5, those got the 1. It's going to be set 4 over 7. The ratio of bong to buck is 4 to 7. Got it? Any questions about this? I know this is a little bit confusing. Okay. So this type of problem, you're going to see this quite a lot for math counts. It's not going to be as complex as this. It's only going to make you go between these two values normally. Okay? And you're still going to make a conversion table, and you're going to see how the words will cancel out. No confusion, minimal confusion, right? All you have to do is set up these tables so that the words will cancel out, and you get your final ratio. All right? So this is a really, really helpful tool. 2 problems here. Give you guys 5 minutes to do these. And when you get your answer, you can chat it to me. I'll give you guys 3 more minutes. The last one should take a while.
Artemis.
All right. So let me go over the solutions. So for the first one, there's a moderate amount of conversions we're gonna have to do. So let's do a conversion table to make things easy. So we know that 4 quarts equals 1 gallon. 8 cups equals 0.5 gallon. 8 ounce equals 1 cup. So now we have these 3 conversions we can do. So we want to find the relationship between 5 quarts and ounces. So what we can do is we can find the ratio between quarts and ounces and then just find how many ounces there would be. So what's the ratio between quarts to ounces? We want to go from here all the way to here. So first we're going to have 4 quarts over 1 gallon. Set up the table. So now we want to cancel the word gallon right here. How do we cancel that? We can multiply by 0.5 gallon over 8 cups. See how the words gallon are going to cancel out? Now I want to get rid of cup and put in ounces. So we're going to put 1 cup on the top, 8 ounces on the bottom. So now you can see the words cup and the words gallon are going to cancel out. All we have left is quarts over ounces. So this is going to equal to 4 times 0.5, which is 2, over 1 times 8, which is going to be 64. 2 quarts, 64 ounces. Same thing as 1 over 32. So this is the quarts, 2 ounces. Now 5 quarts means that we multiply by 5 on both sides. So we got 5 quarts over 32 times 5, which is 160 ounces. All right. Next one, we really need a conversion table. And a lot of you got really close to the answer. You got the conversion table good, and all of that was good. But the problem was to simplify. And yeah, like the numbers are really big, so we ran into some issues there. So let's get started. So we're going to go from pong all the way to egg shake. So first we have 3 pong actually, over 5 ping. Set up all this table. We want to get rid of ping, so we put ping on the top here. 8 ping over 1 ping. See how the words ping are going to cancel out? Now we're going to get rid of ping. Ping to pong. We put ping on the top. 9 ping, 14 pong. I'm going to get rid of pong now and turn it into egg shake. So we got 21 pong to 10 egg shake. The words pang are going to cancel out. The words pong are going to cancel out. All I've got left is pong over egg shake. So now, here comes the hard bit. A lot of you multiply the top, then you multiplied everything on the bottom, but that takes so long. 3 times 8 times 9 times 21, that's going to take an eternity. So what we do instead, we can simplify right here. Okay, we can see that 21 and 14, they cancel out to 3 over 2. 8 and 2, we can see those. 2 gets rid of, 8 turns into a 4. 4 and 10, 10 turns into a 5, 4 turns into a 2. Now what do we have? We got 2 times 9 times 3 over 5 times 5. That's a lot easier, all right? So now we can just evaluate this. 2 times 9 times 3, that's just 162 over 25. That's the answer. So a lot of you guys multiplied the top, then multiplied the bottom, and then tried simplifying these huge numbers, all right? But you can simplify before you multiply them out so that you have much less work to do. All right, so now we're going to have math counts problems, 5 minutes for these, and chat me your answer when you get it. So hint for the first one, represent the number of blue gumballs as 2x, the number of red as 3x, the number of purple as 4x, and then set up an equation to solve for x. Okay, so for the first one, let's do blue is 2x, red is 3x, purple is 4x. So now we're gonna have, so this is the initial. Now we're gonna add 5 red gumballs. So we're gonna have, blue is still gonna be 2x, red is now 3x plus 5, purple is now 4x, still 4x, okay? So now this is the final. Now the probability of randomly drawing a red gumball is 40%. So let's change the statement so that we can better relate it to ratios. This basically means that the percentage of the balls that are red is 40%. This means that 2/5 are red now, okay? Because 2/5 of the time you're gonna pull out a red ball, the other times you're gonna pull out something else, okay? Because this is exactly the proportions of balls. Okay, so 2/5 are now red. This means that the number of red over the total is gonna be 2/5. So the number of red is 3x plus 5 over the total, which is 2x plus 3x plus 5 plus 4x, which is going to be 9x plus 5, equals 2/5. Now we have an equation in x. If you were to solve this equation, I don't have that much space here, but if you were to solve this equation, you would get x equals 5. But wait, this is not the answer yet. You can't just put in 5. You got to look back at the problem. What does it want? How many gumballs in total are now in the bag? Well, the total is down here, 9x plus 5. It's not just, the answer is not 5. The answer is 9 times 5 plus 5. So that's going to be 45 plus 5, 50. All right. Next one, now that we know how to do conversion tables, this one is extremely easy now, right? Because for people who don't know how to use conversion tables, this is really hard because you're really confused. Like, what do we do here? So let's just use the conversion tables. So we want to find ratio of Mary to Bill. So let's put Mary on top. So we have this one right here, John to Mary. 2 John, 5 Mary. Let's get Mary on top because we want to find Mary to Bill. 5 Mary over 2 John. Now we want to cancel out John. So we have John to Bill. 3 John equals 7 Bill. words John are going to cancel out. The ratio of Mary to John is just going to be 15 over 14. And that's it. All right. It's just a really small conversion table. 2 more math counts problems. I'll give you guys until the rest of the end of class, 10:50. Alrighty, so for the first one, the difference of the squares of 2 positive integers is equal to twice the square of their difference. Let's unpack this statement here. The difference of the squares, which means that it's x squared minus y squared, equal to twice, 2 times the square of their difference. So the difference squared. So this is the equation we have. Let's do a little bit of simplifying. All right. So first of all, if you look at this, x squared minus y squared, that's a difference of squares. So let's factor this guy. Plus y. Look, we have an x minus y on this side. This one just turns into 1 x minus y to the first power. So we just have x plus y equals 2x minus y. This is pretty easy now. Just move this to the other side. X equals, not x, wait, 2y right here. X equals 3y. So it's just going to be 1 over 3, and that's the answer. Okay? Last one. So we want to find the ratio of the energy that JZ114 gives off to the energy the sun gives off. So let's say the surface area of the sun is A, and its temperature is T. Okay, this is the sun. For spherical star JZ114 is going to have 10 times the radius, half the temperature. So it's going to be T over 2 to the 4th. But now the area. They give us the radius. It's not the area. So we want to find the relationship between the radius and the surface area. Well, if you don't know the exact formula for the surface area of a star, the exact formula is 4 pi r squared. But you don't really need to know this because you can guess that surface area is a 2-dimensional value, right? 2-dimensional. Radius is 1-dimensional. So 1 squared gets you the 2 dimensions. So radius squared times some kind of constant k, okay? We don't even care what k is. But all you know is that the surface area is proportional to r squared because area is just the 1-dimensional value squared, okay? We don't need to know the exact formula. So all we need to know is that A is equal to some k times r squared. So now I have k times, well, now r is 10 times as large. Okay, so this is the JZ114. So the ratio of JZ114 to the sun is this over the sun. K r squared t to the 4th. We can just do a little bit of simplifying here. Let's unpack this guy. Remember, we can distribute the exponent. So it's going to be 100 r squared. 100 r squared. Distribute the exponent here. E4 over 16. R's cancel out. 100 over 16, that's the ratio. Do a little bit of simplifying. 25 over 4. That's the answer. All right. So that's it for today. See you guys next week.